All right.
All right.
So I will share my screen, but I found that the desktop, the web version, I can share my screen in the web version. So I'm trying to install the desktop version.
Let me see if I can.
I think the web version, I see a share screen button right now on the web version.
Yeah, I
Does it
can
work?
see too, but I can click it.
Yeah,
Oh,
so we can try maybe a different demo first. If you need to install
Yeah.
something or get set up, that's fine.
yeah, I can go. And also, I think maybe only Google Chrome would support the share screen. So maybe if you're using Safari or Firefox, it might not work. And if you're using Chromium, it might not work. I think it might have to be just like good old Google Chrome or
I'm
bad
using
old
Brave.
Google Chrome. Yeah, that might not work because they might not have some kind of WebRTC support that's needed, or some kind of like codec for like H.264. They might not have like the license for it.
Okay.
Okay.
So
So let me share my screen then.
Ivan, you're going to go first? Okay, great.
Yeah, I can go. It's fine. So I'm next on the list anyways, right? Can everybody see?
Yeah.
Yep.
Yes.
Okay. Oh, you know what I should do? Send the repo link first. I think I should do it. Okay. So everyone can see the repo. I think I should have submitted the repo. Okay, so that's the repo. So a quick demo, I guess let's just kind of look at this. So what is off-chain authentication? So basic description is we want to kind of create a token that can represent our identity on the blockchain, but that could be verified off-chain. So in this kind of little project, what we're doing is we're going to sign into a contract and get our access key. In this case, we're going to sign into a Sputnik DAO, and we're going to sign kind of a JWT style token with our access key. And now we can pass this signed token along as kind of an authentication header or any type of authentication kind of to something that's not on the blockchain. And off-chain, we can query the near RPC API and see if this access key is actually indeed valid and if it's assigned to the account in question. So if you are familiar with kind of public-private key cryptography, what we're going to do here is generate a pseudo token. So we're just going to make ed25519 key pair. So if I hit this, here, for example, is our public key. Here's our private key. This is in base 58. And we are creating kind of a JWT style, just a JSON. And this JSON just makes some claims like we're on near. Oh yeah, so like test. Let's say like our account is test.near. So our account is test.near. Our public key is this. So the same key here that belongs to this private key. And for example, we'll just record the epoch. So epoch is just kind of the time number of seconds since the inception of Unix. So we create this and then we generate something called signature, which takes pretty much this JSON here. And this JSON is like no different than say a written contract. And this signature, no different from putting your signature on that contract. This is just this kind of JSON signed. Then we wrap this all up again in base 58. And we have just a long string that just looks like this, like a bunch of mumbo jumbo. And this is our kind of off-chain authentication token. So we can send this kind of to like a Node.js backend. And when we send this to, let's say, our server, so kind of what happens? So let's look at the parse authentication. So we have this.
Ivan, just 1 or 2 clicks maybe.
Yeah. So I lied when I said, yeah. Oh, there you go. It's not really zooming. Let me see. Okay, is that better?
It is, yeah, thanks.
Okay. Oh, it's really slow. Yeah, so it's like frozen right now. Okay, let's let it do its thing. Okay, is it doing too much? Anyways. $50. Oh, okay, that's okay. That's good. So yeah, so we get this long string, and then we kind of decode it. It's base 58, and we produce. We kind of split it up. We parse the JSON. So we parse this inner thing here. We have a provider account, a public key or epoch. Then we kind of decode the signature, decode the public key, and we feed it into this function called signature verify, so sign verify by tweet in ACL. And it's going to just literally return true or false, the signature valid or not. If the signature is valid and our provider is near, we go do a post to near, and we check if this key is indeed tied to the account. If it's not, this access key is not a near, return error, again, on near, error, okay. So kind of a quick rundown, but let's see it in action, right? So if we go here, go to mainnet. So this is mainnet. Let's sign into Sputnik DAO. We're going to sign in Sputnik DAO. So okay, so what is this? So this is our access key for Sputnik DAO right here. And this is kind of the token we have generated, our off-chain authentication token. So let's try to this Node.js server.js that we have. Let's try sending an off-chain request. So this is just going to be carried in the authentication header. Let's see, can we verify it? Oh, okay. So all that what we just saw, yes, what we just saw, everything passed. So this signature is fully valid. This account is indeed mux.near, and this is definitely the public key that's associated to this account, the access key. So let's try changing 1 byte of this signature. So like we're going to change this Y to 0. What happens? Get an invalid signature. Okay. So let's try one more thing. Let's go to our near wallet.
5 minutes.
Yeah, plenty of time. And let's revoke our access key. So this is the access key we just made. Let's deauthorize ourselves from this is the actual wallet, the actual contract to blockchain. And if we try now an off-chain request, we get account is not tied to key. So now this key has been deauthorized. And pretty much, yeah, that's pretty much off-chain authentication in a nutshell. And I mean, there's definitely things you can add to this. This could be standardized to fit kind of a JWT style token. This could have more features in terms of roles, etc. But the basic idea is that. And yeah, I don't know, any questions or things like that?
Is the mainnet like a browser extension? Is that basically a wrapper for this?
Mainnet. No, there's no browser extensions.
Oh, but there's a you have like the MetaMask. You have MetaMask. Sorry, MetaMask browser extension.
Yeah, ignore that.
is that like I feel like that does a similar thing, like almost like a wrapper for what you have. Is that kind of do they have a similar logic, or are you familiar with it?
Yeah, so MetaMask, it has built-in functions kind of to sign messages and stuff, but all MetaMask can do for you is generate you this signature. So you can definitely use MetaMask to have off-chain authentication. So yeah, it's literally the same thing as the MetaMask functionality. If you ever used OpenSea and like you try to mint something, the free OpenSea, because they have the on-chain minting and the free minting. if you do the free minting, you're going to have a MetaMask pop-up that's going to say, can you sign this message to prove your identity? That's kind of exactly what we're doing by signing this JSON.
Okay, yeah, that helps me understand it a lot more, because I was wondering how MetaMask works, and this demo helps me understand that. Thank you.
Yeah, same idea. Just in browser, and MetaMask is just kind of almost the same code, just inside an extension. So yeah. Yeah. Okay.
Can we see the code? So if there is anything you wanted to share about the code itself?
It's pretty simple. I mean, you can just look at it in the repo. It's 2 files.
Yeah, I think we saw the business end of the code already, right? That's what you were showing us earlier.
Yeah, it's literally just this. I mean, if you're interested in the actual sign verify, it just kind of looks like this. So this is kind of the guts of it. Generate a random key pair, then create any kind of text. Like you can just make a text called sign me. Then you sign this text. Now on, let's say, some backend or even inside, I'm not sure if Near supports verifying signatures inside the contracts, but you can verify that this exact text was indeed signed by the holder of this public key, so of their secret key. And pretty much if valid is true, that means that this person signed this text or this assertion or this kind of, I like to look at the text sometimes as a written agreement. Like, let's say you write something, I'm going to send, if anything happens to me, I'm going to send like $20,000 to this person, right? And then you sign it. This is kind of equivalent what we're doing with this signature. We're kind of asserting that this exact binary, this exact information was indeed produced by the holder of this secret key.
Okay, so generally speaking, this project is not about actually the smart contracts themselves, but rather illustrations that you can actually use near blockchain and near Wallet Explorer for some other stuff, which are pretty exciting too, correct?
Yeah, I should have said that at the beginning. There's no kind of smart contract here. There's no smart contract involved. We're just using we're just connecting to an existing smart contract. We can connect to any smart contract to make this off-chain token. In this case, I just choose Sputnik DAO, but it could be any contract, yeah, that we connect to and make access key to, and kind of, yeah. So there was no actual smart contract that was like created or etc.
Yeah, that's great. Thank you so much for that.
Yep.
Ivan, any other questions? Any other comments?